It's chapter 15, number 1. So we're told real estate ads suggest 64% of homes have garages, 21% have swimming pools, and 17% have both. So I made this Venn diagram, and the area that it encompasses is homes for sale. And so we're told that of those 64 have, okay, so anyway, the first thing we're going to put in the Venn diagram is the overlap, which is 17% that have both. And that's the probability that you have a garage and a pool. That's the probability of G and P right there. Let me write that out a little bit bigger. I can't write there. Probability of P and G. That's what I have in there. Okay? All right. So that's the overlap. And then here's the probability of garage. Okay? So what's not part of the overlap? 0.47. In other words, 0.64 minus 0.17. So 0.47 is in this part of the probability of the garage. So this is probability that a randomly selected home for sale is going to have these following things: garage or pool or whatever, or both. And then over here is what's left of the probability of having a garage, having a pool, I should say, exclusive of having a pool and a garage, not having the overlap. That's 0.04. So I just take 0.17 and subtract it from 0.64 and I get 0.47, and take 0.17 and subtract from 0.21 and get 0.04. Okay, so we got probability of garage, 0.64, probability of a pool, 0.21, probability of both, garage and a pool is 0.17. Okay, now A, what's the probability of a pool or a garage? Okay, symbolically that's written P, open parenthesis, P, and then the union symbol G, which equals the probability of P plus the probability of G minus the probability of P and G, which is 0.64 plus 0.21 minus 0.17, 0.68. And you just add the three pieces together and you get 0.68. 0.47 plus 0.17 plus 0.04 is 0.68. Okay, B, neither a pool nor a garage. Okay, so that's probability that a randomly selected house for sale doesn't have a pool and it doesn't have a garage. Okay, not P, not pool, not garage, and. Okay, well we're going to take the complement of a pool or a garage. So in other words, it's the area that's all around these two circles. Well, what's left? Okay, well, we add these two things together. That's 0.68. That's probability of P or G. We subtract that from 1. We take the complement, and we get 0.32. So what's left out here? This is not. I don't know why I have 0.04 there. I don't know. It's 0.32. Okay. So the area that's outside the two circles and the overlap is not P and not G. It's the intersection of the two of the areas that are not of either probability. Okay, and then finally, C, a pool but no garage. Okay, pool and no garage. Pool and no garage. Okay, pool and garage not. That's the symbols. And so we're just going to go up to here. Okay, and that's going to be the probability of a pool minus the probability of a pool and a garage. Okay, so that equals 0.04. The probability of pool is 0.21. Probability of pool in a garage is 0.17. So the probability of a pool and not a garage is 0.04. Okay, now let's go down. Let's just look at this from a different point of view. I'm going to close these inking tools for a second. Go down here. Let me go down here. And I want to go to a new page. Okay. Now I'm going to go back to open up these inking tools again. Start inking. There's a ballpoint pen. Okay. Let me scroll down. Now, let's make a table. Okay. All right. So pool. Yes. No. Garage. Yes. No. Okay. So we're going to put in our probabilities here. So garage is 0.64, pool is 0.21. So pool, yes, 0.21. Okay? And a garage, yes. So the pool goes down, the garage goes across. What do we say the pool? Okay, I don't remember what the heck the pool was. 0.64. Okay, and the probability of both is 0.17. So here's how we fill it in. We put in the total for the garage. It's over here. The garage. So here's vertical, so the yeses goes over here. Here's the total for the pool, and then here's the part that's both. 0.17, yeah, okay. So this is the probability of the garage right here. And here's the probability of the pool right here. And this is the probability of the pool and the garage right in here in this little box here. Now, we know that this plus this has to equal this. And so this is going to be what the heck was that? 0.64, 0.47. Okay. So this is probability of pool and, I'm sorry, probability of not pool and garage. Okay. All right. And this is 0.04. This is the probability of pool and not a garage here. Okay. Now, all four of these probabilities inside these inner squares must equal 1. Okay, and this is 0.32. This is the probability of garage complement and pool complement. So in other words, this is neither garage nor pool, 0.32. Okay. And this is going to be 1.00 here, so we're going to have 0.36. This is probability of not a garage. And what is this? 79. Yeah. Probability of a pool, not a pool. Okay, not a garage, garage. Pool, not pool. Is that right? Yeah. Okay. All right. So you can fill this table in the same way you filled in the Venn diagram, and it's another way to look at it. They're both valid. The thing is, the table will work with more than two variables. The Venn diagram's only going to work with two, with an intersection. Okay, but you can, depending on what you're trying to do, the table may be more useful too. And that's about it for